Like equation with rational exponents. Now, sometimes you may be given an exponential equation such that the exponent of x is a rational number. So you can have an equation of the form x to the power of m over n. X to the power of m over n is equal to a constant. And you are supposed to solve for x. Okay? Now, there are some techniques that you are supposed to know. Okay, generally, if you are given an equation like that, you can just solve for x by making the coefficient of x equal to 1. To do that, you multiply the exponent of x by its reciprocal. The reciprocal of m over n is n over m. Okay? The reciprocal of m over n is equal to n over m. Okay? So we multiply the exponent by its reciprocal. So whatever you do on the left, you also do it on the right hand side. Be aware that the exponent of a here will be equal to what? 1. So you multiply the 1 by the reciprocal of the exponent of x. Then you solve for x. Like for example, if I give you an equation like say x to the power of a half is equal to okay, well let me put 9. Right? Like this. Based on the knowledge you have so far, you just take square root on both sides and solve it. But that's not the only way of doing it. You can just multiply the exponent of x by its reciprocal, which is 2. You do the same on the right hand side. So the final answer will be x is equal to 81. So if you put 81 where there is x there, 81 to the power of a half is the same as square root of 81, which is a 9. Okay? So be aware of this concept of the reciprocal. Right? Now, we also have some special cases. The first case, okay? The first case, when x to the power of m over n is equal to a, if a is positive, okay? If a is positive, and m is even, your answer will be x equal to plus or minus a to the power of n over m. Okay? Right. I'm going to summarize those special cases later on. So you can have a case where the constant a is positive and the m, which is the numerator of the rational exponent of x, is an even number. Remember, when you are trying to solve for a, you interchange the numerator and the denominator of the reciprocal. Okay? Right? Or rather of the exponent of x. So if m is even, like for example, in this case here, okay, our numerator, which is more like m, it's an odd number, but the denominator is even. When I swap the 2 here, when you swap the 2, you end up getting the denominator as being even. Right? Now, that has got an influence in terms of your answer. So when a is positive, m is even, you always get two answers, positive and a negative. Right? I hope you are aware that if I give you minus, okay, let's say minus a to the power of the half times minus a to the power of the half. This is the same as a to the power of the half times a to the power of the half. You get the same answer. Okay? Right, so that's what this means. And then the second case, you can also have your a as being negative. If a is negative, then either the m or the n can be even. Then you have no solution. Right? You are going to see this case. Like for example, if I give you, say, x, right? X to the power of, let's say, 3 over, okay, x to the power of 3 over 5 is equal to, I put 4. 4. But for now, okay, if you simplify this, because you haven't done higher order mathematics, you simplify this x to the power of 3 over 5 equal to that, you end up getting x equal to 4 to the power of 5 over 3. So you end up needing to find the cube root of what? The cube root of 4. The answer would become a decimal. But there are cases where we might not be able to find the solution at all. Okay, in this case, you have to find it. It's going to be a decimal, maybe 1 comma something, and so on. Right? So when I do examples later on, we are going to encounter these cases. Okay, it will be better for you to understand them when I'm doing an example, which I will do just now. Right? Now I'm giving some of you an opportunity to copy that down. Please don't copy down this illustration. Okay. But once you're copying, let's say instead of putting a positive 4 here, if I put a negative 4, right? I put a negative 4, it means that you end up having to find the cube root of negative 4, right? Is it possible to find the cube root of negative 4? Well, if you try to find it, it's going to be a number which has got decimals. It won't be an exact number. Can you try to read for me? Use your calculator. What is the cube root of negative 4? What is the cube root? Yeah. So that one, it will give you an answer which is a decimal, right? All right. Now let me get on to the next one. Now, some of the possible cases that you can encounter are these ones here. Well, what I'm going to do is you need to sit down and just go over this step. So you can have an exponential equation like that, x to the power of m over n is equal to a. Now, we have got two cases when it comes to the value of a. If a is positive, right, your m and your n can either be both odd, okay? Now, the solution will look like that, which is the simplest case of an exponential equation with rational exponents. This will be the simplest case, okay? Like, for example, x to the power of 3 over 5 equals 8, straightforward, it comes 8 to the power of 5 over 3. You find the cube root of 8, which is a 2. You multiply that 2 by itself 5 times, and you get a 32 there, right? So the answer here will be a 32. Okay? Now you can check with the calculator. 8 to the power of 5 over 3 is 32. Right? Then you can also have a case where a is positive, n is odd, and n is even. Right? When you solve this, you get x to the power of 8 power of n over n. The only difference is that the n is now even. It's not odd as in the first scenario. So you end up coming up with that. Okay? Then you have another case where the m is even, and so on. The good thing is you can get solutions for these three cases. Right? You can get solutions. Right? Then it becomes a little bit complex when the a is negative now. There are cases where when a is negative, you might not get a solution. Now those two cases are when m is odd, n is even. Also, when m is even and n is odd. Okay, now you get a better understanding of this when you start doing proper examples. Okay, but just go over this table here when you are solving exponential equations with rational exponents. All right? Okay, today we have got 2 periods, so we'll try to go over as much as we can. Okay. It's not ideal to have a math lesson in the afternoon, usually for 2 periods, but you should be able to enjoy it though. All right. Right, so in your book, just write examples, then we'll start doing let me give you a class exercise. You try one. Can you try to do number 10? Class exercise number 10. Number 10. After you finish doing number 10, we'll take a short break. Okay? Then we carry on now. Yes? Please do number 10. Just write class exercise in your math workbook and do number 10. I'll give you about 2 minutes to do that.
Sir, that's the power of minus two.
Yes. Number 10. You're doing number 10. Let's say if I give you x to the power of minus a third, and I ask you, what's the reciprocal of minus a third? Right. So here, you multiply this by negative 2/1, and then you get you see, I expect you all to have that ebook because it's my lecture series, so you should have it on your phone. Okay, by now you should have found the answer. By now you should have found the answer. All right.
Wait, sir, a few more minutes, please.
Number 10. We don't have all the time. We don't have all the time. All right. So here you have minus 16 x to the power of minus 2 over 3 plus 4 is equal to 0. Okay? Now in my case, the first thing I'll take that positive 4 to the right, so that, or if you want, you can take the minus 16x to the power of negative 2 over 3 to the right. If you do that, you end up getting 16x to the power of minus 2 over 3 is equal to 4. Okay? Are you following that? Then, now, let's look at the exponent of x. It's a negative 2 over 3. If you want to find its reciprocal, it's going to be what? Negative 3 over 2. So you multiply the exponent of the 4, so this becomes x to the power of 1. But I think to avoid confusion, let me just write it down. So this is minus 2 over 3 times minus 3 over 2. This would equal to 4 to the power of minus 3 over 2. Okay? Now, look here. Is it possible to simplify this? So you get 6x, sorry, 16x is equal to that. I can write this as the square root of 4, all raised to the power of minus 3. Yeah, right? So, I'll end up getting what there? 2 to the power of negative 3, which is what? 1 over 8. So, you end up getting 1 over 8, and on the left hand side, you've got 16x. So, your x is going to be 1 over 16 times 8 is what? 10 times 8, that's 80. 6 times 8, that's 48. So add the 2, you get 120. So it will be 1 over 128. Okay? Now you can test if the answer is right. Put x equal to 1 over 28 here and simplify it, you'll see. Okay, wait, let me check if I didn't make a mistake. From here to there, that's fine. Right? Then 4 to the power of negative 3 over 2. This one here. I can write the square root of 4 raised to the power of minus 3. There's no problem there. The square root of 4 is a 2. 2 to the power of minus 3. It's negative what? 2 to the power of minus 3 is 1 over 8. We get 1 over 8. I don't think I made any mistake. What is 2 to the power of negative 3? It's 1 over 8.
That's what I think.
You see, it says minus 16 plus 4. I want to check if you have the
Wann haben Sie alles an? Oh, I did. No, but there it
Okay. All right. I think I see where I made the mistake. Right. I see where I made the mistake. You see, I didn't raise this 16 here to the power of minus 3 over 2. Okay, that's where the problem is. So let me read you the question. Let me read you the question. But when I redo it, I'm going to do it slightly different from this. All right, first thing, can I have your attention? I'm going to write this as 16x to the power of minus 2 over 3 is equal to 4. Are we all clear with that? Huh? Right? Then from there,